Guys, so let's prove now the De Morgan's laws. In the previous video, I explained all the concepts attached to De Morgan's laws. So let's do question A and question B. All right, so we have our A is B intersection C complement, which is the same as B complement union C complement. So I'm going to prove that this is equal to that. So I'll move from the left hand side to the right hand side. So how do I do this? I'm going to say, okay, I'm going to introduce X. I'm going to say, let X be a member of B intersection C complement. All right, now here you cannot go further expanding this if your set, this entire set, is bound by this complement. So we have to remove this complement. Now how do we remove this complement? We're going to change this sign here. We're going to say if X is a member of this set complement, meaning that X is not a member of this set, because it's part of the complement, isn't it? All right, so I've removed it. So if you want to remove the complement, change the member to sign here, change it to not a member of. Now guys, if what does that mean here? What does this mean? If X is not a member of B intersection C, it means X is not a member of B, or X is not a member of C. All right, I know intersection means and, isn't it? Now intersection means and if we have a member to symbol here. Now since we have not a member to of symbol here, meaning we're going to use or, not and. Are we together? Now guys, if X is not a member of B, it means X is a member of B complement, isn't it? If X is not in B, it means it's in the complement of B. Maintain the sign, or X is a member of C complement. Now if X belongs to B complement or C complement, if it belongs to either B or C, it means X belongs to the union of these two. All right, we have solved, isn't it? All right, now here you are not done. You have to now prove. Now you have to do the conversely. You have to go now backwards. You have to go now from here to there. You have to do conversely, or the other way, you have to do the vice versa, isn't it? You have to now go back to that, then you can get the full marks. So we have moved, yes, we have moved from this side to the other side, but we have to go back now from this side to this side now. So we're going to say conversely, or you can say vice versa, right? So we're going to start from here now. We're going to say, okay, let X be a member of B complement union C complement, right? Now it's just like you're just going back. Check how you answered though, just like you're going back from this step to this step, isn't it? So what follows? This step is the same as this step, right? So what follows after this step? It's this step if you're going backwards. We're having this if you're going backwards, right? We're having this if you're going backwards. Check again backward. What follows? It's like we're having something like this, isn't it? If you go backwards, right? Again, if you go backwards, check, we're having something like this. All right, so here this is C. Just go backwards. If you check backwards, we're having that. All right, if we check backwards again, the next step after this, we're having X is a member of B intersection C complement, isn't it? Hence shown. So you're going to have the full marks. All right, let's do B. So guys, B is saying we have B, which is B union C. We have a complement, has to be equal to B complement intersection C complement. So we're going to say let X be a member of B union C complement. Now remember what I said earlier, you cannot go ahead solving if you have a bracket here, bracket, open bracket and close bracket, and there's a complement here. It's like this set is bound by this complement, so we have to remove this complement. And how do we remove this complement? By changing this sign. So if there's a member of, we're going to say not a member of, then the complement, it disappears. All right, so if X, now how do you read this? this is read like this. So if x is not a member of the union, it means x is not in B and x is not in C. I know for union you always say or, isn't it? But since we have not a member of, you cannot use or here. You can only use or if we have a member of there. Don't confuse them. All right. So how do you go further here? If x is not a member of B, it means x is a member of B complement. Maintain the sign, and x is a member of C complement. All right. Now, if x is in B complement and x is in C complement, it means x is part of the what? Of their intersection. Isn't it? It's part of the intersection of the two sets. Okay, you have solved there. You have proved to that, right? Now you have to go backwards. Conversely, you have to say conversely or say backwards, right? We're going to say let x be a member of B complement intersection C complement. All right. Now what? It's the same as this, isn't it? This is the same as that. So it's like, as I said earlier, it's like you're going backwards on top. So just repeat the steps backward in backward form. So after this step, there's this step. So I'll just write it the way it is. X is a member of B complement and x is a member of C complement. Then after this step, they followed something like this. All right. After this, they followed something like this. They followed something like this. After this, they followed something like this, isn't it? So you're just going backwards. All right, it's shown you have answered. All right, guys. So this is De Morgan's. Or let me also help you with this question as well. So let's now do this one where we have A complement equal to A, isn't it? So I'm going to say let x be a member of A complement, right? Now, as I said earlier, I cannot go further if there is a bracket and the complement here, right? I need to remove the complement, isn't it? I need to remove this complement. How do I remove this complement? I'm going to change the sign here. I'm going to say x is not a member of A complement. Now, if x is not a member of A complement, it means x is a member of A, right? I've shown. Now, you have to say conversely or backwards, right? We're going to say let x be a member of A. Conversely is like you're just going upwards, backwards. Have you seen this? This is the same as that, right? What step follows after this? X is not a member of what? A complement. What follows after this? X is a member of A complement. You have answered there. All right. Now let me just comment on why it has said verify the De Morgans here. Now when you're verifying the De Morgans, you don't answer the way we answered. You bring in sets. You can say let, you just bring in sets. You can say let maybe set B be equal to, maybe you say 1 to say 8, and maybe set C is equal to, just make sure that they have maybe say 3 to maybe 5. There just has to be some members which are existing both in B and C, right? And the universal you say from 1 to 10, right? Then you can prove that. That's how you can verify or show. Proving, you bring in these stuff of the let the value of let x be equal to, let x be a member of that. That's how you prove, right? But for verifying, you need to bring in these why I say let x be, or let B be a set of maybe from 1 to 8, C be maybe from 3 to 5, then the universal 1 to 10. That's how you verify or show. But for proving, you have to bring in these guys why I say let x be a member of something. That's how you, that's the difference between proving and verifying. Verifying, bring in sets, numbers. Proving, you say let x be equal to something. That's how you prove. Alright guys, so this is more about De Morgans and also the other question. Alright guys, thank you for watching us. This is Zitfuse tutorials, one of the best, not one of the best, but the best tutorials. Alright, so see you in the next video, and you can feel free to subscribe, share as well, and yeah, and comment the questions that you feel like we need to tackle. Thank you so much.